Okay, welcome back. Last time we worked with adding, subtracting rational expressions with the same denominator. Now we want to look at adding, subtracting rational expressions with different denominators. Okay, so the first issue is to match up their denominators. In other words, find the least common denominator, which I'll just write as LCD. So the way I like to do it is to sort of completely factor and then kind of match the denominators, okay, in a weird sort of way. So here, let's look at the first kind of problem. They give you, in these problems, they give you two fractions and they want you to find the LCD. Eventually, you'll just be adding them together. Okay. Okay, so the numerator at this point doesn't really mean very much to us. It's this denominator that we're interested in. And what we're going to do is get the prime factorization. Okay, so 15, 3 times 5 times x times x. 6x to the fifth is 3 times 2 times x times x times x times x times x. Okay, so the key is to multiply things in over here to make it look like this and vice versa. Okay? So you're always asking yourself, what is this side missing that this side has, right? So this side seems to be missing a 2. So I'll multiply in a 2. It seems to be missing 3 x's. Okay, so I can multiply in 3 x's. Now I go over to this guy and see what he's missing, right? So this guy and this guy look pretty much the same, except, oh, this guy's missing a 5, right? So I'll have to multiply in a 5. Okay? Once they look exactly the same, that thing is the LCD. Okay, so 3 times 5 times 2 is 30. And then we have x to the fifth. There's 5 x's there. And that's the idea. It's all this, it's a matching game, basically. Trying to balance things in, okay. So number 6, we have 2 all over x minus 5, and then 3 all over x plus 7. Okay, this time the denominators are already factored, right? X plus minus 5 is prime. You can't break that down anymore. X plus 7 is prime. You can't factor that. Okay? So I ask myself, what is this denominator missing? Well, it's missing the x plus 7. So I'll multiply that in over here. And over here, what am I missing? I'm missing an x minus 5. So once you get them in balance, looking exactly the same, that is your LCD. Okay, so that was a little easy. Let's look at one where the denominators maybe are not factored. Okay, so 14, number 12, 14 all over y squared minus 49. And then I have 12 all over y times y minus 7. Okay, so I factor. Y squared minus 49 is a difference of squares. So that'll be y minus 7 times y plus 7. And then this guy is already factored for us, right? So it's y times y minus 7. And then I play the matching game. What is this guy missing that this guy has? Well, it's missing a factor of y, so I need to tack on a y here. And then what is this guy missing that this guy has? Well, it's missing this y plus 7. So tack on a y plus 7. So my LCD, y times y minus 7 times y plus 7. Okay, let's try one more, and then we'll actually get in there and see if we can do some of these. This is all prep work so far. This is number 16. 7 all over x squared minus 5x minus 6. And then we have x all over x squared minus 4x minus 5. Okay. So take my denominator. This one, I'm going to factor it in the two binomials. The signs have to be plus minus. And then I think it's 6 and 1. So we want the bigger number to be 6. And the bigger number to be negative and the smaller number to be positive. Let's go for this guy. X and x, plus and minus. And we're probably going with 5 and 1 again, right? So we want the big number to be negative. Okay, then play the matching game. So what is this guy missing that this guy has? Well, he's missing an x minus 5. And then what is this guy missing that this guy has? Well, he's missing an x minus 6. And then that's your LCD. Okay, so now let's, now that we have this kind of matching idea in our pocket, let's try to apply it to actually adding and subtracting rational expressions with unlike denominators. Okay. So the process will be similar. It's just this number here that that was missing. The way it'll work, you'll have to multiply this on the bottom and top of the rational expression. So recall, you can literally, and this maybe it's not even a recollection at this point, but you could take any number and multiply any fraction and multiply top and bottom by anything you want, as long as it's the same, because it's equivalent to multiplying by 1, right? So 7 6 times 1 is 7 6, right? You agree, right? Well, what is 1? Well, I can rewrite 1 as 1 over 1, for heaven's sakes. So this must be equivalent to 7 6 still. And then you could always rewrite 1 over 1 as basically anything over anything, as long as it's not 0. So you can write 5 over 5. The point is, if you're given 7 over 6, you can multiply top and bottom by anything you want, so long as it's the same. You can multiply top and bottom by 4 over 4. And this will still equal 7 6, because ultimately all you've done is multiplied by 1. Okay. Seems crazy, but it's true. So that's sort of the other bit of information we need to do our construction. Let's dive in and see how it goes. So 5 over 6x plus 7 over 8x. I'm going to, instead of kind of doing an arrow and matching, what I'm going to do is just factor it as it sits in the denominator and do all my matching there. Okay, and I'm going to leave a little room for the missing parts. And when you put in missing parts, it's not just putting it here. Now you have to put it here and here. Okay, it's this idea that you're multiplying top and bottom by something. It's not really changing it. Okay, and then plus 7 all over 8 is 2 times 2 times 2 times x. Leave a little room. Okay, so I asked myself, what is this guy missing that this guy has? Well, it's missing 2 2's, right? So I need a 2 and a 2. Okay? And if you do it to the bottom, you have to do it to the top. So up here I go 2 times 2. Okay? And then what is this guy missing? It's missing a 3. So I multiply here by 3, but if you do it to the bottom, you have to also do it to the top. Okie dokie. So 5 times 2 is 10, times 2 is 20. All over 4 times 2 is 8, times 3 is 24x. Plus 21 all over 24x. Okay, keep going forward. So add the numerators over the common denominator. 20 plus 21 all over 24x. Then we got 41 all over 24x. And I don't think there's any common factors. I think 41 is prime. Okay. Keep moving. 24, 3 plus 1 over x. Okay. 3 is the same as 3 over 1. So now to have the same denominators, I need to multiply in over here by an x. It's missing an x. You may say, well, this is missing a 1, but no, not really. We can always assume there's a 1 sitting there. It's not going to change anything, right? So when I do multiply out, I'll get 3x all over x times 1 is x, plus 1 times 1 is 1, all over x times 1 is x. And so there was no need to multiply top and bottom by the 1. That was a bit silly, right? Okay, finally add the numerators over the common denominator, 3x plus 1 all over x, and you're good to go. Okay, so next, number 30, 3 over x plus 4 over x minus 6. Okay, so the bottom's already factored. I'm just going to leave myself a little room. So this denominator is missing a factor of x minus 6. So I'll multiply that in top and bottom. Over here, we're missing then a factor of x. So it needs this x now to balance it. So what do we have? 3x minus 18 all over x times x minus 6 plus 4x all over x times x minus 6. Now we can add our numerators over the common denominator. 3x plus 4x is 7x's. And I don't think there's any simplification. These guys don't have any common factors, so I'm stuck. The top is prime. I can't factor it anymore. There's no common factors between the top and bottom, so I'm done. Let's go on to 34. So the first denominator is already factored. We just have the y plus 1 down there. Second denominator, it's 3 times y. Okay. So this denominator is missing a factor of 3. And then it's also missing a factor of y. Then this denominator is missing a factor of y plus 1. Okay. Then we can clean it up a bit. 3 times 3 is 9y all over 3y times y plus 1 plus 2y plus 2 all over 3y times y plus 1. Then you want to add the numerators over the common denominator. So it's going to be 9y plus 2y plus 2 all over 3y times y plus 1. 9y plus 2y's is 11y's, and then plus 2 all over 3y times y plus 1. I think that's all we can do. So we just have a whole mess of these to sort of get through. I'll just be doing problems from the book from this point on. Okay. Let's look at 38. Okay. Okay, so downstairs it's already factored. You just have x plus 6. And this denominator is already factored x minus 6. So this denominator needs an x minus 6 in the top and bottom. And then this denominator needs an x plus 6. Okay, so I have 8x minus 48 all over x plus 6 minus, if you wish, 2x plus 12 all over, oops, and the denominator is x plus 6, x minus 6. Okay, now I'll subtract the numerators over the common denominator. I have 8x minus 48 minus, and you have to be careful, you're subtracting the entire numerator. So put those parentheses around the 2x plus 12. Okay, and then distribute the negative. Eight x minus 2x is 6x, minus 48 minus 12 seems like minus 60. And I think that's all you can do. Keep moving. Number 42. This time the denominator is not factored. We're going to have to factor this guy, see what it is. Looks like a difference of squares. So I need y plus, y minus. Square root of 16 is 4, so 4 and 4. Minus 5 all over y plus 4. So this denominator is missing the y minus 4, so I'll need to multiply in y minus 4, y minus 4. And then I think I'll be good from there. So 8y all over y minus 4, y plus 4, minus 5y minus 20 all over y plus 4, or if you'd rather y minus 4, y plus 4, it doesn't matter. Combine the numerators, so we're subtracting. I need to indicate that with a parentheses. Okay. So I'll have 8y minus 5y plus 20 all over y minus 4y plus 4. Then 8y minus 5y is 3y plus 20. I think that's good. You don't have to multiply out the denominator. Leaving it factored like this is sometimes better. Again, you're always looking to see if there's a common factor on the top and bottom. This time you can't factor anything out of these two terms. There's no GCF, or greatest common factor. So there's no like terms here to cancel out. Let's try 50. So 3x plus 7 all over x squared minus 5x plus 6 minus 3 all over x minus 3. I'm going to factor the denominators, try to match them up. So this is x minus, I believe it's 3 and 2. Okay, so this guy's missing a factor of x minus 2 on the top and bottom. Okay, now I need to subtract the numerators. So again, you need to indicate that with parentheses. You're subtracting the entire second numerator, not just part of it. Distribute that negative. Simplify. Oh, I think I made a mistake somewhere. No, there's a mistake in my notes. Sorry. I'm right. Okay, so 7 plus the 3x minus 3x is 0, and then 7 plus 6 is 13. Okay. Looks like we have 5 more to go. Let's look at number 60. There is an end to the marathon eventually, but it's going to be a bit. Okay, so I need to factor the denominators. Oops, you can pull out a 5y from the first one. You pull a 5 out of the second one. So this denominator is missing a y. Multiply top and bottom by y. And let's just go ahead and subtract the numerators. Let's just go ahead and get it all done over the common denominator of 5y times y minus 1. $66. So 7 is the same as 7 over 1. And in order to get the same denominator, we need to multiply this one top and bottom by x minus 5. That should get the job done. Okay. So we're going to have 7x minus 35 over x minus 5 plus 1 all over x minus 5. And then add the numerators. So that would be 7x minus 35 plus 1 should be 7x minus 34 all over x minus 5. Let's keep going. 72, we have x all over x squared minus 10x plus 25, and then minus x minus 4 all over 2x minus 10. I need to factor those denominators, see what I'm looking at. Hoping it's minus 5, right? I think it is. And then the other guy, minus x minus 4, and the numerator all over, factor a 2 out. Okay, so this denominator is missing a 2. Multiply top and bottom by 2. This denominator is missing an x minus 5. So we'll have 2x all over 2 times x minus 5 squared. Then minus, if I FOILed this out, I get x squared minus 4x minus 5x is minus 9x plus 20. And I have to subtract the numerators over the common denominator. Indicate that with a parentheses. Distribute that minus in, so I get 2x minus x squared plus 9x minus 20 all over 2 times x minus 5 squared. Simplify here. Looks like I have a minus x squared plus 9x plus 2x is plus 11x minus 20 all over 2 times x minus 5 squared. Let's look at 78. Y all over y squared minus 1 plus 5y all over y squared, whoops, y minus y squared. Okay, I want to factor the denominators, sort of open them up, see what you're dealing with. So this is difference of squares for the first one. Second one, I can factor out a y. Okay, this has an opposite. One thing I notice is this guy and this guy are opposites. So if I just change the sign, it'll fix that part of it. Okay, I might get carried away with the other stuff just yet, but at least let me fix that part. It's equivalent to basically factoring a negative out of this and then plopping it in front of the fraction. Plopping the negative in front of the fraction. I'll give you this. Now I'll worry about fixing the denominators. So I need a y in the top and bottom on this one. And over here, this guy's missing a y plus 1. So I'm ending with y squared all over y times y plus 1, y minus 1, minus, if I distribute, 5y squared plus 5y all over y times y plus 1 times y minus 1. Now I want to subtract the numerators over the common denominator, so y minus parentheses 5y squared plus 5y all over y times y plus 1 times y minus 1. And I have y squared minus 5y squared minus 5y all over y times y plus 1 times y minus 1. Combine like terms, minus 4y squared minus 5y all over y times y plus 1 times y minus 1. And I could factor a common factor of y out of the numerator. Here I see there's common factors of y's. I can divide those out, and I'm left with negative 4y minus 5 all over y plus 1 times y minus 1. Okay, let's look at one more. This is 86. Okay. Factor the denominators. First one's a difference of squares. And second one is 8 and 7. So our first fraction is missing the factor of x minus 8. And the second fraction is missing a factor of x plus 7. So I have to smush that in there on you. Sorry. So I have 3x minus 24 plus, no, just, let me get my fraction set up. 3x minus 24 over x minus 7, x plus 7 times x minus 8. Then plus 2x plus 14 all over x minus 7 times x plus 7 times x minus 8. Then add the numerator over the common denominator. So 3x minus 24 plus 2x plus 14 all over x minus 7 times x plus 7 times x minus 8. 3x plus 2x is 5x. Negative 24 plus 14 is negative 10. And either I made a mistake or I made a mistake in my notes. Made a mistake here or in my notes. Oh, I wrote it down here wrong here. I'm sorry. I wrote it down wrong here. This is not number 86. It's like number 86. Okay, 86 is different because it has three fractions to add. We might as well take a look at it. In my haste, I screwed it up. Okay, so 3 all over x squared minus 49 plus 2 all over x squared minus 15x plus 56 minus 5 all over x squared minus x minus 56. Okay, that's what it's supposed to be. Sorry. Okay, so factor all the denominators. Leave a little room because you're going to have to find a common denominator. Okay. So this one's missing an x minus 8. This one's missing an x plus 7. This one's missing an x minus 7. Okay, then clean up. I'm going to go ahead and distribute in the numerators. Okay, then add the numerators, add and subtract the numerators. Use a parentheses when you subtract. Distribute the negative. And combine like terms. So 3x plus 2x is 5x's. Minus 5x's is 0. Oops, crossed out the wrong one. 24, negative 24 plus 35 is 11. 11 plus 24 is 25. And then that's it. Okay, so that finishes this section. We'll see you next time.